In this lesson, you want to determine for each rational expression the values for the variables for which that rational expression is undefined. Now, remember, we're using the word undefined here, so let's remind ourselves about something. So in order for a rational expression to be undefined, if you think about a rational number, so if I have, let's say 6 divided by 0. So remember, if we have 6 divided by 0, we can never divide by 0. So that's what we mean by undefined. So a rational expression is undefined when the denominator is 0. When the denominator is 0. Okay? And it's okay for the numerator to be 0. It doesn't matter. So if the numerator, just want to remind you, if the numerator is 0 and the denominator, let's say, is 7, that's 0. Okay? So that's the only time a fraction is undefined is if the denominator is 0. So a rational expression is undefined when the denominator is 0. All right? So for example, let's just look at this example for a moment. So number 1, we have let's say we have 4 divided by x minus 5. All right, we're going to look at an easy one to begin with. So if we look at this rational expression, all you got to do, based on the direction says find all numbers for which the rational expression is undefined. So the rational expression is undefined when the denominator is 0. So you just look at the denominator. Don't worry about the numerator. It doesn't matter what the numerator is. All you do is look at the denominator. All right, so just think about the denominator, and in your mind you're asking yourself this. So you're saying, well, where is this expression equal to 0? That's what you got to find out. And so notice that when I took this denominator and set it equal to 0, I have this linear equation. Okay, so that's the first thing you want to do. So the first thing you want to do is take your denominator. Take your denominator and set it equal to 0, because that's what you want to find out. Where is this 0? Now, we all know just by looking at this what value of x makes the denominator 0. Yeah, so you knew it was 5, right? Okay, but it's not going to always be that simple though. So that's why you have to, it is necessary that you think of it in terms of, well, where is this denominator equal to 0? So I have this linear equation, and so if I solve for x by adding 5 to both sides, I get x to be 5. All right. Now, here's how you write your answer. So usually it's going to be there's probably a couple of ways you can write the answer. All right. So listen to what I'm about to say. So in my math lab, and even on a worksheet or a test, it'll say something like this. All right, so your answer is going to look like this. So you're going to say the expression is undefined for x equal 5. That's what you would say. So in other words, if I use any other number for x, okay, that means every other number, any real number will make this expression defined except 5. That's what that means. So in other words, if I let x be 8, think about that, my denominator is 8 minus 5, which is 3, right? So I get 4/3. That's defined. So this rational expression, you remember a while ago in a previous lesson, we evaluated. So I let x be -3, and I got a real number back, right? So that means that this rational expression was defined for x equal -3. It's also defined for an infinite number of other real numbers, except whatever makes this denominator 0. Okay? So here, this rational expression, when I substitute 4, is defined. Okay? So when I substitute 4, I got this real number. So what this is saying is that I can substitute any real number for x except 5, and when I substitute that number for x except 5, it's going to be defined. All right? So based on the direction, it says find all numbers for x for which the rational expression is undefined. The only number that makes this undefined is 5. Every other real number makes it defined. So I want you to think. So note, every other real number, every other real number makes the expression defined. Makes the expression defined. Okay? All right, so that's what that means. All right, now let me go ahead and talk about the way you can write the answer. So you can write the answer as the expression is undefined for x equal 5. Sometimes depending on the textbook, sometimes the answer could be written as this. Okay, so you can say this. So you can say x cannot equal 5. And that's what we said, right? That's this right here is basically the same thing we said here. Every real number makes the expression defined except when x is 5, or you say is defined, but x cannot equal 5. All right, so there are two ways to write the answer. The expression is undefined for x equal 5, or you can just say x cannot equal 5. Okay? All right, number 2. Number 2, let's suppose we had negative 12 divided by 17x. Now, for some reason, that throws students off. And it should not. It should not throw students off, because remember, you're trying to find out the numbers for which this rational expression is undefined. And all you do is look at your denominator. Look at your denominator. All right, so here's the next step. So the idea is to look at the denominator and set it equal to 0. And again, you have a linear equation. But to get x by itself, see how you're multiplying by 17? The opposite is to divide by 17, right? So let me go ahead and rewrite this over. So you divide by 17, and 17 divided by 17 is 1. 1 times x is x. But what's 0 divided by 12? Well, that's 0. So what that means is this. What that means is that x equals 0 is the only real number I cannot use. Every other real number will make this expression defined except 0. X equals 0 makes this expression undefined. Okay? So here's how you write the answer. So you're going to say your answer. You could say the expression is undefined for x equals 0. Okay? So that's one way to write the answer. The other way you can write the answer is this. You just say x cannot equal 0. Okay? All right, so that expression right here, I can use any real number for x except 0. That's what I found. All right, so that's number 2. Number 3, let's suppose we had this for number 3. We had 6x divided by 2x plus 9 times 3x plus 2. Okay? So 6x divided by 2x plus 9 times 3x plus 2. So I have this rational expression. And so remember, I want to find out for what values of x is this rational expression undefined. Okay, so where is it undefined? Well, remember, rational expression is undefined when the denominator is 0. So all you do, so think about that big idea. So the big idea is that you take this you take this denominator and just rewrite it, and you set it equal to 0. All right, now notice this should now make some sense from the previous module that you learned. Notice that this is a polynomial equation that's been factored. See, it's factored. Those are factors. And so remember in the previous lesson, when you have a product of factors and that product is 0, then remember the 0 factor property says that one of these must be 0, right? So notice that this is already factored for you. And so just use the 0 factor property. So I get 2x plus 9 is equal to 0, and 3x plus 2 is equal to 0. And notice you have two linear equations. Just like you had a linear equation here, just like you had a linear equation here. You just solve for x now. And so here, I'm going to get, let me move this over a little. All right, so I'm going to get 2x equals a negative 9. And so therefore, if I divide both sides by, I'm going to write this over. And so if I divide both sides by 2, I get x to be negative 9 halves. All right, over here, I get 3x. If I subtract 2 from both sides, I get 3x equal negative 2. Divide both sides by 3. I get x to be negative 2/3. All right. Now let me remind you what that means. Okay. So what does that mean? You got to know what that means. What does those two numbers for x means? It means this. It means, remember how we got them? We got them by setting equal to 0. So that comes from your denominator. So that means this. That means that x equal negative 9 halves makes this denominator 0, which means that the rational expression is undefined. Negative 2/3 makes this denominator 0. Okay, because remember, negative 2/3 comes from this one. So this factor 0 when x is negative 2/3. So that makes this denominator 0, which means that the rational expression is undefined. All right, so based on the direction is find all numbers for x for which the rational expression is defined. So your answer is going to be something like this. You're going to say the expression is undefined for x equal, and on my math lab is going to say separating by commas. So just make sure you do that. Make sure you do that because if you don't separate them by commas, if you just put a space, it's gonna mark it wrong. You gotta make sure you separate it by commas. So just do commas on paper as well. So negative 9 halves, comma, and then negative 2/3. Okay. So that means, remember what that means. That means this expression is defined. So remember, let me just kind of remind you what that means as well. So this means that this expression, the rational expression, is defined for all real numbers, except these two. So except x equal negative 9 halves, comma, negative 2/3. All right. Okay. Now remember, another way you can write the answer is by saying this. So you can say x cannot equal negative 9 halves, comma, negative 2/3. Okay. All right. So that was number 3. Okay. So let's look at number 4. Number four, you have this. Okay, so let's suppose this number 4, x, let's do y, I'm sorry, y squared plus 3 divided by y squared minus 2y minus 3. Okay? All right, so I have this rational expression, and the directions is, where's this rational expression undefined? Well, remember, rational expression is undefined when the denominator is 0. So take the denominator, rewrite the denominator, and set it equal to 0. And then you got to solve this equation. Well, notice, guys, what kind of equation is this? You learned that in the previous module. That's a quadratic equation, right? And so you solve this quadratic equation by factoring. And so if I factor, and then at some point I have to use the zero factor property, just like I use the zero factor property here. Okay? So you got to remember some things you learned in the previous module and in previous courses. So if I factor this, I get y, the last sign's negative, so the signs in here are different, and I want to get a negative 2y. So the only possibility is for you to say y minus 3 times y plus 1. Okay? And always double check though. Make sure you have time. Make sure to go back and make sure you get this back. So the outer is a positive y. The inner is a negative 3y. When I add them up, I get a negative 2y. And some students mess up on the last, so be careful. Make sure you get that last back. A negative 3 times a positive 1 is a negative 3. Okay? So now I can use a zero factor property. So I'm going to set each of these equal to 0. So I get y minus 3 equals 0, y plus 1 equals 0. And notice I have this linear equation. So I'm going to go ahead and solve for y. So when I get y by itself, I get y equals 3 and y equals negative 1. So what I found is this. I found that the expression is undefined for y equal 3 and y equal negative 1. Y equal 3, comma, negative 1. That's what I found. Okay, so another way you can say that is this. Another way you can say that is that y cannot equal positive 3, negative 1. Okay, because when y equals a positive 3, this denominator is 0. That's what that means. And if that denominator is 0, this rational expression is undefined. And you can check it, for example, 3. What's 3 squared? Okay, that's 9. What's 2 times 3? That's 6. And what's 9 minus 6? 3. And what's 3 minus 3? 0. And you can do the same thing for negative 1. Okay? So again, this rational expression is undefined when y is 3 and when y is negative 1. Okay? Now, let me just remind you about this. So what you just found is that this rational expression is defined for all real numbers except y equal 3, that's 3, and negative 1. That's what you found. Okay? All right, number 5. Let's suppose we had this for number 5. We have x minus 7 divided by 4. X minus 7 divided by 4. Okay, so let's look at that. So in all the other problems we had, go back to all the previous 4 problems. Notice your denominator contained a variable. Your denominator contained a variable. Your denominator contained variables. Number 4, your denominator contained variables. Now look at number 5. What do you notice about number 5 about your denominator? That's 4, right? That's a constant. There's no, this is not a variable expression right here in the denominator. So basically what that means is this denominator is always going to be a 4, won't it? All right, and so the question is, remember, to find where a rational expression is undefined, you look at the denominator. So the question is this: where is 4 equal to 0? It never is. Never. 4 is never equal to 0, right? So this means that the rational expression is never undefined. That's what that means. Okay, so this means that the rational expression is never undefined. So how do I write the answer then? You may say, well, how do I write the answer? Well, let's look at the directions again. So the direction is find all numbers for which the rational expression is undefined, right? So you can say this. You can say something like, there are no values of x for which the rational expression is undefined. You can say something like that, right? So that, let me finish this. Rational expression is undefined. And that basically is what the question was. So or what the directions were. So the directions find all numbers for which the rational expression is undefined. Well, there's no variable in the denominator, so this rational expression is never going to be undefined. Okay. Now, you can also say this. See how I wrote there are no values of x for which rational expression is undefined. You can also say this. You can you can condense this statement to something like this. You could say the rational expression is never undefined. Okay? So those two mean the same thing. And I want you to think about this. So remember in some of the problems we went ahead and we talked about what that means, what we found. So the rational expression is defined for all real numbers except, in this case, 3 and -1. So we can do the same thing here. We can say right here, we can say you can also say this, answer the rational expression is defined for all real numbers. Okay, so all those three things can answer the directions here. All right, find all numbers for which the rational expression is defined. Okay, all right, so that's number 5. And again, something like that does throw students off also. Okay, let's look at number 6. So number 6, let's suppose we had this. Number 6. So we have x minus 2 divided by 3 minus x. All right, so that's not a bad one, right? So if now notice I do have a variable in the denominator, and so I want to find out where's this rational expression undefined? Well, a rational expression undefined when the denominator is 0. So you don't even worry about the numerator. If you go back, we never even looked at the numerators at all. We just looked at the denominator, and we asked ourselves, where's this denominator equal to 0? For what value of x is the denominator equal to 0? Now, the easy way to do that one, again, this is linear. The easy way to do that one is just to add x to both sides. And so when I do that, I get 3 equal x. So I found, x. So I found what x is. Okay, so what I found is this. I found this in terms of the answer. I found that the rational expression is undefined for x equal 3. I can also write it like this if I want to. I can also say x cannot equal 3, right? All right. So again, what all this means is that this rational expression is defined for all real numbers except what? 3. So this rational expression is defined for all real numbers except x equal 3. So that's what all this means. Okay? But in terms of the answer to the question, to the directions, put one of these two. Okay, number 7. Number 7, you have b minus 2 divided by 3b minus 12. So b minus 2 divided by 3b minus 12. Again, that's an easy one as well. So if I want to find where this rational expression is undefined, I look at the denominator, and it just turns out that when I set the denominator equals 0, because a rational expression undefined with the denominator 0, I get a linear equation. So if I add 12 to both sides, I get 3b equals 12, and divide both sides by 3, I get b to be 4. So in terms of the answer, you can say this. You can say the rational expression is undefined for b equal 4. Okay? You can also say this. You can also say b cannot equal 4. So I can use any number for b except 4. Okay? So this rational expression is defined. So remember what that means. That means that this rational expression is defined for all real numbers except b equal 4. Okay? All right, number 8. Let's suppose we had this for number 8. We had x squared minus 16 divided by 2x squared minus x minus 10. So I have this rational expression, and again, the directions are, where is this rational expression undefined? Well, again, a rational expression is undefined when the denominator is 0. So just go off to the side and do that. So you ask yourself, well, when is this denominator equal to 0? Okay, now notice number 7 was easy, right? Number 7 was easy because when I set the denominator equals 0, that was linear. That was a linear equation. But what kind of equation is this that I end up with right here? That's quadratic. And in the previous module, at the end of the previous module in our course, we learned how to solve quadratic equations. And so in that lesson, we did this by factoring. Now, not all quadratic equations are factorable. That's a different lesson later on in the course. But for us right now, they are factorable. So this polynomial here on the left side is factorable. So we go ahead and factor this. So you get 2x, and then what's going to work for that negative 10 will be a negative 5 and a positive 2. Always double check. So the outer is a positive 4x, the inner is a negative 5x, and I get negative x. And again, double check the last. Sometimes students mess up with the last. Negative 5 times a positive 2 is a negative 10. Okay? Now, so I factored this correctly. So now remember, the zero factor property says if you have a product of factors that's 0, then one of those factors has to be 0. So you set each one equal to 0. So 2x minus 5 equals 0. X plus 2 equals 0. And notice you have two linear equations now. And so you just solve for x. So here 2x equal 5. And so therefore x equal 5 halves. Over here, you get x equal negative 2. So in terms of your answer, you're going to say this. Now remember, the question was, find all values of x for which this rational expression is undefined. So you're going to say the rational expression is undefined for x equal 5 halves, comma, negative 2. Okay? And you can also say this. You can also say x cannot equal 5 halves, comma, negative 2. Okay? All right, number 9. Let's suppose we have this in number 9. Okay, number 9. We have y divided by y squared plus 36. Y divided by y squared plus 36. Okay, so if I look at that, so again, I have this rational expression, and you want to find out where's this rational expression where's this rational expression undefined? Well, a rational expression is undefined when the denominator is 0. And so notice, look at what I have. I have this quadratic equation, right? But notice, if you look at y squared plus 36, isn't that the sum of two squares? And so remember, the sum of two squares cannot be factored. So you may say, well what do I do? When is this equal to 0? Well, look at it. Y squared plus 36 is never equal to 0. Because look, if I get y squared by itself, just to kind of explain a little bit better, you get y squared equal to negative 36, right? Well, if I square a number, if I square a negative number, is that ever going to be negative? A negative times a negative is a positive. If I square a positive number, that's never negative either. And if y is 0, 0 squared 0, that's not negative. I'm sorry, that's not 0. So this right here, so y squared plus 36 is never going to equal 0. No matter what you try and substitute for y, it's never going to be. So then you ask yourself, well, let's go back and talk about the directions. So the direction said find all values of the variable, in this case y, for which the denominator is 0. Well, there isn't any. So that means that the rational expression is always defined for all real numbers. That's what that means. Okay, so in terms of the answer, you want to say would be something like this. You would say something like the rational expression, and remember, it goes back to the one we had earlier. Let me just quickly find it. So it's kind of like this one here. Remember how this rational expression was never undefined? And so you can say one of these three things right here. And that's the same thing here. This is never undefined. So the rational expression is never undefined, something like that. You can say something like there are no values. There are no values. There are no values of y, in this case y, the variable y, for which the rational expression is undefined. Is undefined. Okay? All right, that's number 9. Number 10, I suppose we had this in number 10. We had 6 plus 12x divided by x cubed minus 4x squared minus 21x. Okay? So I have this rational expression. And I want to find out, where is this rational expression undefined? Well, remember, a rational expression is undefined when the denominator is 0. So remember, in every case we've done, if you go back and you look at all the previous 9 problems, all we did was we took the denominator and we set it equal to 0. And so in a previous lesson, you see, how did you solve this polynomial equation? Now, it's not quadratic, it's cubic, but what was the first thing you did? What do you think you can do here? Well, you can first of all factor out an x, couldn't you? The GCF here is x. So I can factor out an x, and so I get x times x squared minus 4x minus 21 equals 0. And then, if you remember, you then try to see if you could factor this trinomial right here, this quadratic trinomial, and you can. So I get x times, and let's see, that's going to be x, and then 7 and 3. 7 and 3, and then 7 will be negative, 3 will be positive. And always double check, the outer is 3x, the inner is a negative 7x, and when I add them up, I get negative 4x. And then a negative 7 times a positive 3 is a negative 21. What I want you to notice there, if you think about the previous module, at the end of the previous module, you have 3 factors, right? So I'm going to set each one equal to 0, so using a 0 factor property. So I get x equals 0, so I'll solve for x is already by itself. Here I get x minus 7 equals 0, which means x equals 7. And then here I get x plus 3 is equal to 0, which means x equals negative 3. So there are three values for x for which this rational expression is undefined. So the answer, you're going to say the rational expression is undefined for x equals 0, 7, negative 3. Okay? And then you can also say this. You can also say x cannot equal 0, 7, negative 3. Okay? All right. And then finally, let's look at number 11. So number 11, you have 4m divided by m squared plus 10m. Okay? And again, you want to find out for what values of m, in this case, is this rational expression undefined. All right, so remember, a rational expression is undefined when the denominator is 0. So we got to figure out, well, where is this denominator equal to 0? Well, how do you solve this polynomial equation? Yeah, so first thing you do is you notice that I can factor out an m. And so when I factor out an m, I get m times m plus 10, right? And so notice that I have a product of factors, and that product is 0. So the 0 factor property says that either this one's 0 or this one's 0. So m equals 0, m plus 10 equals 0. And you just solve for m. Well, m's already by itself here. Over here, if m plus 10 is equal to 0, to get m by itself, I'm going to subtract 10 from both sides. So I get m to be negative 10. So those are your 2 values of m for which this rational expression is undefined. So you're going to say this is your answer. You're going to say the rational expression the rational expression is undefined for m equals 0, comma, negative 10. And then another way you can say this is that m cannot equal 0, comma, negative 10. Okay? All right, so that part of our lesson, the way that we wrote these answers, go back over that and look at the way we wrote the answers. Go back over all of these and look at how we wrote the answers. The way we wrote the answers was based on the directions here. So the directions was find all numbers for x for which the rational expression is undefined. Okay, so that was that. That's another skill you have to be able to do with rational expressions. Find out, well, where's this rational expression undefined? Okay, all right. So that's going to be the end of this lesson.